Now, we will demonstrate our application. We will start with the management app, which is used for management purposes. After that, we will continue with the resident app, which is designed for unit owners and residents. So let's start with the management app at adm.srusun.id. So, what is the management app? This is the core platform designed for vertical houses, as known as rumah susun. From a single dashboard, management can oversee buildings, units, residents, and IoT devices such as water and electricity meters. There is some rules in this app. First, the system administrator who has full access across all the vertical houses in the root level. Second, the building administrator who manage only their building, adding towers, floors, and units, also appointing managers. In practice, this role usually held by the Association of Owners and Residents, as known as P3SRS. And last, the building manager, responsible for daily operations such as adding residents, controlling, and monitoring utilities. This role usually carried out by the building management body, as known as Badan Pengelola Rumah Susun. Let's start to explore management app. We are entering the management app as a system administrator. Let's log in, and the login succeed. After sign in, we land on the dashboard. The left menu groups is everything we manage, like building structural, such as vertical house, towers, floors, units, also people, like residents and managers, and also IoT related, such as devices, components, and emulator. So this is dashboard page. On the dashboard, we can view the cumulative traffic of utility usage in the building. The utilities whose traffic is monitored here are water and electricity. So the system administrator privilege can view traffic from all registered buildings. For example, here we select Rusunami di Jardin Cihamplas and we click start streaming, and we can stop the streaming. So the streaming already stopped. By default, we viewing current in amperes from electricity and flow rate in liters per minute for water. We also can switch to another metrics. Okay, so from electricity, let's start to switch to total energy, and for water, let's switch to volume. And the electricity meters is kWh and volume is meter cube. So we can see the cumulative water and electricity consumption. We can also click the units, another units of measurement like this. For example, and we also can see another buildings. So, for example, we want to see the green Pramuka city. Click start streaming, and the streaming is starting and stop. So, different building show different results of the traffic. Okay, so let's move to building section. So in this in this page, we administrate each building, such as name, address, number of towers, floors, and unit. We also can add a new buildings or edit an existing one. Here, the building organized into tower, floors, and units. We will take a look at each of the entitles. So this is the tower page, and in this page, tower represented within the building complex. Each tower has a certain number of floors and units, and also we can add a new tower. This is the floors page. On this page, we can see the number of units on each floor. Each floor belongs to a tower. We can also edit as existing towers and add the new ones. So this is the page for of residential units, and these are the units that are owned or rented. Various towers and floors are shared common assets. Each unit is linked to an owner and an occupant who may be different people. With complete data, it becomes easier to monitor who owns and who occupies each unit in the building. Next, there is also resident page that manage account for residents and owners. This data serves as the basis for accessing the resident app. Each owner may hold more than one unit across multiple housing complexes. So, for example, owner 1 has one unit at Rusunamide Jardin Cihamplas. Owner 2 has one unit at Green Pramuka City. Owner 3 has 3 units at Grand Asia Africa, all within one complex. And owner 4 has 10 units spread across 3 different buildings. So, in addition to residents, there is also a manager's page. Here, we can add the managerial personnel for a building. Each account can access only one building. There are 2 available roles to choose from: administrator and manager. Okay, so we already in the core section, devices. This is the first IoT devices page related with IoT. Currently, we can see 3 real IoT devices have been installed in the unit as a pilot project for this development. Each device is identified by its MAC address, device name, and building related fields such as unit, floor, and tower, and also the building name. And these components are registered. The IoT device can access the application via the REST API using the API key. So, for example, let's open unit C63 at Rusunami The Jardin Cihamplas. Here, we can view more details about the device installed in unit C63 at Rusunami The Jardin Cihamplas. We can see the device's status and types of devices available in the housing. The current status is offline, with the last update timestamp indicating the device is still unconnected. The sensor and actuator types are water and electricity. There are controls here to turn off the sensors and actuator. If we turn off an actuator, the unit's utilities will be cut off. This feature is very useful for policy enforcement. For example, if a resident violates the rules, the unit can be remotely shut down. We can also view the commands that have been executed in history section. When registering an IoT device, we need to load the registered configuration onto the device so it can connect. The configuration can be downloaded here. Okay, so this is the example of the configuration. It stores the data used to link the device and some IDs in unit ID, flat ID, device name, component ID. This information is already saved in database. So when the IoT device connects to the server with this data included, server and device already recognize each other. This is the components page. We can add the configuration for various IoT types here. For example, there is several components, sensor and actuator here that we only use water and electricity sensor and actuator, but for the future, we plan to develop security IoT who need gas sensor, humidity sensor, and flame sensor. Each sensor and actuator has its own processable measurement unit, keeping the application flexible for future IoT needs. Lastly, there is the emulator page. Since developing and installing IoT devices takes more time, we also built a digital entity that emulates device behavior. One benefit of this emulator is to test the system's resilience under high traffic if the devices are deployed across thousands of units. Case for example, there are already 16 emulator registered here. We can also see the further page and we can see the emulator already online, same like devices before. So that is all the feature available in the management app. So we will using administrator user in Rusunamin the Jardin Ciamplas building. Let's log in and the login succeed and we see the same page as system administrator before. However, when we choose something related with buildings, we only see one buildings available, which is Rusunami de Jardin Ciamplas. This is because this role can view data for only single buildings within its assigned area of responsibility. Likewise, other building related data, like building, towers, it only show the one building name here, like towers, floors, and another, something like devices, component, and another only show from same building, Tsunami Jardin Cihamplas. But when we click a residence menu, it doesn't have access to this data. Administrators do not have access to resident data. Their permission cover only for building administration, manager, and device. So to access resident data, it's only can use a manager account. So let's log out and we come back to here. Now we switch to manager role. So we see the same interface appears as in the other rules. But however, in building section, we cannot adding any entities of the buildings. Same like in towers, we cannot add anything. We only can view the buildings related. However, the manager can manage ownership data and occupant data and can view each person of ownership and occupancy status. For example, we can see which building from the same buildings here that have by, have owned by the residents. And another features are same. So let's log out again. That concludes the explanation of the management app. Next, we will continue with the explanation of the residence app. So this is the resident app. Resident app site is in app.srusun.id. What is resident app? Resident app is a mobile web application for residents and owners of units in buildings to monitor utilities and IoT devices. And also, there is some feature to pay utilities using a prepaid token system. The main difference between resident app and management app, it's more focused on units owned by the residents and occupants by the residents also. So it's more simpler UI than management apps. And the features first is IoT monitoring, same like before is electricity and water with switchable metrics, IoT control with actuators, water and electricity per unit, prepaid utilities with buying tokens, and balance increase. Usage auto deducts from balance. Also, top up and balance checks and needs to view tokens and balance, multi-unit and multi-complex support in a single account. So if the residents have the more than one unit, it's also appear even the buildings are different. And also with the secure access with OTP to the WhatsApp. Now we will buy a token to one of the unit. First, we can choose which unit who want to us to buy the token and where we used to buy this and we buy for 250,000 rupiah and there is some update for the MDR merchant discount rate is here and the task. So we already get the total. And this app is still in prototype phase, so we assume that the payment succeed like this and we can see the token added like this. In Tower B it's added for sure. And in this account, all the unit here is created by emulator. Let's see. So the unit is like this. So we can see some graph in water like flow rate and volume. Volume it's mean the accumulate volume and electricity with current, frequency, PF, total and voltage. So like that because this is the emulator we cannot turn off the electricity here. The token balance will be decreased when we refresh the page. For example, like this, in every seconds it will be decreased, and we can see how fast we use the utility such as electricity and water in this example. So it will be create awareness for user about the amount of the usage of utilities, and it's our goals to save. So let's come back to last section. This is the real device at the unit. This device shows date and the metrics for the utility. So we will use the case to the real unit with real IoT device installed in current unit in Rusunawa Medajar Ciamplas. 3 units there. So let's insert the username. The username is owner and this is the number, and trying to send OTP, and we get OTP from WhatsApp. It's 503290. It succeed, and this is the page for real installed device like this. Now we will take some experiment to see the effect of the control at the mobile app in the real unit. We will try at 2720 units. In this case, the electricity in turn on condition and also the water in on condition. So we will turn on the television like this, and this television will be represented of the electricity at the unit. So we will try to turn off the electricity. We will tap turn off and the command succeed, and the television it's really turned off. That means it's turn oning condition succeed. We will try to turn oning again the electricity. We will tap the button to turn on the electricity. Okay, so the television turned on, the lamp especially, and the television getting to turn on. We will try the experiment for the water, and we try to make the water at the wastafel is open. We can see at the graphic the flow it's getting changed. Define the axis of the water flowing. And now we try to turn off the water, and that succeed. And now Water in off condition, and the flow also so decrease and even getting zero. Now we try to turn on the water. The turn on succeed and water flowing again, and we can see the increase of the flow from the graph. Okay, we can see the increase of the flow here. So that's all our application demo, and thank you.